Solve the equation 3 sine theta minus 2 equals 0 for theta to two decimal places, where theta is greater than 0 but less than 360 degrees. To solve this problem, we want to use our 4 steps below, where our first step is to solve for our trig equation. In the question, we're given the equation 3 sine theta minus 2 equals 0. But we want to isolate for sine theta. So we first add 2 to both sides, and we're left with 3 sine theta equals 2, and then we divide both sides by 3. And we're left with sine theta equals 2 over 3. So now that we've solved for sine theta, let's identify the quadrants. We know that sine theta has a positive value, which means we must use the quadrants where sine is positive. In quadrant 1, all trig identities are positive, and in quadrant 2, only sine is positive. So we have our two reference angles in quadrant 1 and in quadrant 2. Now the next step is to find the values of these reference angles. To find these reference angles, we want to use our equation of sine theta. So we found that sine theta equals 2 over 3. But because we're not using exact values, we want to use a calculator to solve for theta. And we know to find theta, we take the inverse of sine of its ratio 2 over 3. And plugging this into our calculator, we find that our reference angle is 41.81 degrees. So now let's write this on our graph. Instead of our reference angles, we have 41.81 degrees in both quadrants. Now that we found our reference angle, let's use our graph to find our solutions. In this question, we want to find the standard position of terminal arm 1 and terminal arm 2. To find the standard position angle of terminal arm 1, we simply use the reference angle. But to find the standard position angle of terminal arm 2, we have to find the angle that will look like this. So we'll label the angle in terminal 1, theta 1, and the standard position angle for terminal arm 2, theta 2. We know theta 1 is a reference angle, so theta 1 gives us 41.81 degrees. But to find theta 2, we need to find the difference between 180 degrees on the x-axis and our reference angle of 41.81 degrees. And subtracting these two values together, we get an angle of 138.19 degrees. So we solve the equation to find that theta has a value of 41.81 degrees in quadrant 1, and theta 2 has a value of 138.19 degrees in quadrant 2.